Okay, so 8.10 is the disk method revolving around other axes. It says recall the volume of a solid, so the same formula we wrote in the last one, which is volume is equal to the integration of a to b pi times r of x squared dx, where r of x is us revolving around the x-axis. And when we were revolving around the y-axis, we said r of y. Okay, but we're not rewriting the formula every single time. It's just so you know. Okay, so it says find the volume of the solid formed revolving the bounded region about a given line. Set up the integral, but do not evaluate. Okay, so again, I'm going to set it up and give you the answer if you want to practice integrating and see if you get the same answer later. So we're just setting it up. Okay, number 1 says y is equal to 3 minus x squared and y is equal to 2, revolved about the line y is equal to 2. Well, since my equations here are in terms of x, which means I have y equals, that's how I know I'm revolving around the x-axis, because this is in terms of x. Same thing for number 2. Since those equations are x equals something, that means I'm going to be revolving around which axis? The y-axis. So not necessarily the axis itself, but the direction in which we are revolving. Okay. So first I'm going to draw my graph. Okay. So one thing that I need on this graph is I'm going to end up needing the intersections. So before I do that, I'm just going to draw my line. So y is equal to 2 is up here. And then I have y is equal to 3 minus x squared. So that is going to be up here. And then I mirror it, so do a reflection over the y equals 2. Okay. And so if I'm revolving around that line, I'm going to get circles, just like before, because I'm spinning around it. Okay. The only thing that I need that I do not have just yet is, again, these intersections in order to figure out what my bounds are going to be. So in order to find those intersections, I just set the two equations equal to each other. So I have 2 is equal to 3 minus x squared, and then I solve for x. So I would subtract 3 over, divide by negative 1, so I get x squared is equal to 1, and then take the square root on both sides, and I get x is equal to plus or minus 1. So I have negative 1 here and positive 1 here. Okay, which means I can now set up my integral. So I have the integral from negative 1 to 1, okay, pi. And then this is where it's a little different, because no longer am I looking at an axis to a function. I'm looking at two separate functions. Okay, so before, the reason why we only wrote that one function is technically we were doing 0 minus something, or something minus 0. That's why we didn't write it. Well, here we're going to be doing the function top minus bottom. Okay, so if we're looking at this function here, okay, the top function is going to be the parabola. Okay, the bottom function is that line. Okay, so I'm going to do the top function minus the bottom function, and that is my r of x. Okay, so that is 3 minus x squared, the top function, minus 2, the bottom function, squared dx. So again, this is top minus bottom. And remember, when we're dealing with the other way, it's going to be right minus left. Okay, so if you want to practice integrating, what you should get is 16 over 15 pi as your answer. Okay, number 2 says x is equal to 2 minus y squared and x is equal to 1. Revolve about the line x is equal to 1. So again, I'm going to draw my graph. I have x is equal to 1, which is right here. And then I have 2 minus y squared. So that's going to be on this side. Okay, and then I'm going to mirror image it on the other side. Okay. Which means I need to find these intersections here. And I'll do that again by same method, setting the two equations equal to each other. So I have 2 minus y squared is equal to 1. Subtract 2 over, divide by negative 1. I have y squared is equal to 1, which is y is equal to plus or minus 1. So I have positive 1, negative 1. These are my bounds for my integration. Again, I'm revolving around x is equal to 1, so I'm going to spin around this in a circle, which means my circles now look like this because I'm revolving around in that direction. Okay, so then I have the integration from negative 1 to 1 pi, and again, since I'm looking at a different direction, I'm no longer looking top minus bottom, but right minus left. Okay, so if I'm looking at just this part, okay, not my mirror image, just this part, which one's the right function?
1.
Good, the 1. And then my other function is going to be, oh, sorry, let me rephrase that. I'm looking at the entire thing. Okay, sorry, I'm looking at the entire thing. So my right function is the mirror part. Okay, so it's the quadratic. My left function is the line. Okay, so this is 2 minus y squared minus 1 squared dy. And again, this is right minus left. And again, if you want to try to solve that, you would get the same answer, 16 over 15 pi. Okay, again, what I'm going to emphasize, if you're going to do this by hand, just make sure that since it's being squared, that's the same as writing the parentheses twice and foiling. Don't make the mistake of distributing your square in there, okay, because that's an algebra mistake. We're trying to avoid that. Yes?
Wait, how is 2 minus y to the second the right function?
Because we're looking at the entire function, including the mirror.
Oh, okay.
Yeah, that was my bad. I phrased it wrong in the beginning. Okay, any other questions before we look at 3? Okay, so number 3 says y is equal to 2 to the x minus 3, and y is equal to negative 2, and x is equal to 3. Revolve about the line y is equal to negative 2. Okay, so since this is in terms of x, my revolution is going to look like it's revolving around the x-axis in this direction. Okay, versus the other direction. So first thing I do is I always draw my graph. Okay, once I have my axes up, I'm going to do the equation 2 to the x minus 3. Okay, so well, actually, let me do that one next. I'll just do y is equal to negative 2. It doesn't really matter which one, but I need these boundaries to help draw my e to the x, or 2 to the x minus 3. Okay, so here is x is equal to 3 and y is equal to negative 2. Okay. So 2 to the x minus 3 is going to look like this. Okay. I'm then going to mirror it on the other side. Okay, and once I mirror it on the other side, I'm revolving around y is equal to negative 2. So I know that my circles are going to look like this. So again, I'm revolving it around this part here. Okay, so since this is in terms of x, I am looking at the x-axis. What would my bounds be? So from 0 to 3. Okay, I know it's 0 because it is bounded right here at this axis, and then 3 because it goes up to x is equal to 3. Okay, so then I write this out. So this is going to be pi, and then I do my top function minus my bottom function. Okay, so my top function is going to be which one? 2x minus 3. 2 to the x minus 3. And then my bottom function is, good, so I do minus a negative 2 squared dx. Okay, of course you could simplify this by doing minus a negative, which is plus a positive, and then combining those constants at the end. Again, if you want to practice integrating this, I didn't do this one by hand, so this one's not in terms of pi, but if you were to calculate it in a decimal, it would be 88.74, which is about 28 point something pi.